All right, good evening, everybody. Today we're going to take a look at 3.5 factoring polynomials with the graph. And good evening. Sorry I'm not there for the next couple days. Got some other stuff I got to take care of, but I'll get you a lesson here today. So what we're going to do today, we're going to look at this first polynomial, y is equal to 3x to the fourth plus 12x cubed minus 3x squared minus 12x. We're just going to use this as an example of how we're going to factor a polynomial. In other words, how we're going to get it into factored form. So in other words, we're just going to write it as linear binomials. We are not introducing imaginaries. We'll do that next week. But we are going to talk about how to factor it, and we're going to talk about how to get the roots out of it, and how to make a good looking graph of it. Okay, so here's what we got to do first. So we're going to take a look at how do we find the potential look at what we do first. So we got this puppy out here. Let's take a look at one. I'm going to write steps and then show the work underneath it so you can follow along as you're going home tonight. So what do we got to do? First thing is we always got to look to take out what they have in common. We got to look to take out those common factors. Take a look. Okay, look at all of these puppies. What do they all have in common? Well, they all have at least one x, and they all have a 3 in common, so let's take that out. We take out a 3x, that just leaves us with x cubed. We take out a 3x, that leaves us with 4x squared. We take out a 3x, that leaves us with a minus x. We take out a 3x, that leaves us just a minus 4. That's just a simple algebra. We're going to look to do that every time. We do have to keep that common factor out there, though. We cannot just set it off to the side or anything. So notice, this is not equal to 0 right now. We're not trying to find the x-intercepts. This is equal to y, so this is still our output. We're just manipulating it. We will set it equal to 0 when we take a look at our x-intercepts. Second thing, what are we going to do with just this part that's left over? So in other words, what we're going to do through this continually is we're just going to make it simpler and simpler and simpler and simpler and simpler until we've got all the factors out. We're just going to take the leftovers and we are going to list the potential factors. How do we do that? We have a p and a q. Is what they typically are, but I'm not even going to use that term. We're going to take a look at the constant term, the one that has no x's. And we're going to divide the factors of the constant term by the factors of the leading coefficient. Now you're going to say, the leading coefficient 3. No, it's not, because we're just looking at the leftovers in there, and we're not looking at the whole thing. Just so you are aware, for your book, they call the top P, they call the bottom Q. So we're going to list all the factors of the constant term. The factors of -4 would be 4, 2, 1. But it also, because it's negative, it could be plus or minus, could be plus or minus, could be plus or minus. Then we're going to divide that by the factors of leading coefficients. Now stay with me, people. What's our leading coefficient? Okay, I couldn't hear you, people. What's our leading coefficient? That's right, our leading coefficient is 1, so just plus or minus 1. Now here's what we got to do. Say our leading coefficient was like 3 there. Then we'd have to kind of combine the terms. So we'd have to take all of the factors of the top divided by all the factors of the bottom to see what we'd have out. And somehow I have a viewer on the internet right now, which is kind of interesting to me because I'm recording this for tomorrow, but maybe one of you is super overachieving and watching as I do this live. Maybe you're following me on YouTube or something. Okay, so let's do. So our list of potential factors for this, we're going to take all of these and divide them by all of that, which will give us plus or minus 4, plus or minus 2, plus or minus 1. Which one's more likely to work? None of them. They're all pretty equally likely to occur, but we'll take a look at those and see what we got to do after that. Which one do you want to try first? Okay, let's try 2 first. How are we going to determine it's a factor? Well, let's go back to our old friend 3, then we're going to run synthetic division. On the factors. Every time we make it easier, and you're going to have to do a couple of these till you got this down. Every time we run this through, we're just going to look at the factors that are left over. We're just going to deal with leftovers now, dealing with the whole original thing. We're making it easier, making it easier, making it easier. All right, let's take a peek. So we're going to run synthetic division. So let's try. I heard a 2 first, so let's run with that. What do we run as our coefficients up here? Coefficients up there. 1, 4, negative 1, negative 4. Okay, so we've got 1, 4, negative 1, negative 4. Okay. Carry the 1 down. That's a 1, 2. Add them together to get 6. Multiply to get 12. Get 11, 22. That gives us 18. Now, real quick, is that a factor? No, it's not. Why? Because our remainder is not 0. Again, let me emphasize that. Why is it not a factor? Because our remainder is not 0. Okay, give me a second. I got to drop this for a second. Okay, think real quick. What number should we try next? Which number should we try next? Which number should we try next? Which number should we try next? I heard a 4. Let's try negative 4. I have a feeling negative 4 works. Let's try negative 4. So negative 4, what's our coefficients again? Same as before. Let's try it out. 1, negative 4, ooh, 0, 0, negative 1. Does that work out? Did I make a mistake here? 1, nope, nope, nope. Negative 1 times negative 4, that gives us an 8. Did I make a mistake? Haven't been sleeping a lot. I should check my math. Did I write my factors out right? Negative, oh, that should be negative 4. That's why that doesn't work out. Thank you, Mackenzie. I could hear you saying that even from here, from yesterday. That doesn't work out to a 0. Sorry, that should be a negative 4. Why? That's a negative 4 right there. So what does that mean? That means that that factors. Okay, so what do we get after that? Now, how did I know negative 4 worked? I don't know. It was just one of my factors. My list of potential factors, which again is the constant term divided by the leading coefficient. That gave me plus or minus 4, plus or minus 2, plus or minus 1. Those are my factors of 4. 1 is just plus or minus 1. Tried 2, didn't work. Tried negative 4, did work. Okay, so let's write what we got. So, what do we have? So I had y is equal to 3x. That was in front. Then we were dealing with the leftovers. I know that 4 is a factor, so x minus, excuse me, negative 4 is a 0 then. So x plus 4 is a factor. Why? Because then that would be our 0. Remember, synthetic division uses the zeros, not the factors. So x plus 4 is your factor. What's left over then? Constant, excuse me, remainder, constant, x squared. So we got x squared plus 0x minus 1. Now, just to get some complaining out of the way real quick. Oh, Beckman's not here today. We don't have to learn. Yeah, you do have to learn stuff. Just because I'm not there doesn't mean you don't have to learn anything today. Yes, you got to pay attention like you always do. Let's finish it up, though. So now we've got what we took out in common, found our first factor. Now that we got it down to a squared, because it's squared, now we go back to the previous unit. We could factor to finish it off, or we could use quadratic formula. Which one do you think is easier? Well, let's see if it factors first. What does that factor to? Yeah, plus or minus 1. So 3x, x plus 4, x plus 1, x minus 1. So kind of odd. We started out with this original problem up here. What did we do first? We took out what they had in common. Took out what they had in common. Once I took out what they had in common, I listed the potential factors. Those are my list of potential factors. I tried to run synthetic division. 2 didn't work, so I know 2 is not a 0, so x minus 2 is not a factor. Tried negative 4. That worked because negative 4 is a 0. X plus the root is a factor. Then once I had that down, I realized I down to a square, so I can take care of that to x plus 1, x minus 1. So now I've got it down into my factored form. How do I know when I got it down to my factored form? Because I've got it all down to linear binomials. Okay, what does that mean? Next step. In step 4, what are we going to do? We're going to find our x-intercepts. What does that mean? We take each one of these terms and set them equal to 0. What do we do then? Solve that. X is equal to 0. X is equal to negative 4. x is equal to -1, and x is equal to 1. So in other words, at every one of these locations, this is where it crosses the x-axis. Where it crosses the x-axis. Now, we'll learn in the next unit, what if it was like, or later on in this example, what if it was like x plus 4 quantity squared? Then it's not going to cross it. It's actually just going to kind of bounce off it, because that's something called a double root. Alrighty, that's what you got to learn today. Now, I don't want any excuses. I'm not kidding you guys. I don't want you to say, oh, I don't have to learn because Beckman's not there. Yeah, you still got to learn because Beckman's not there. Beckman's not going to come back and reteach this all to you. You got to pay attention and take notes while you're there. Stop and check out. Questions real quick? Oh, that's a great question. There are 4 roots. If you remember back, we talked about at the very beginning of the year, the degree of the polynomial is the most possible number of roots it could have. And it goes back to the, well, I haven't mentioned that word yet in class, so we won't go there. Okay, let me try an example real quick. Now, you're going to say, oh, I got a sub today. I don't have to wear any. Yeah, you got to do any work. You're in honors. That's how life works. If you don't want to do work, shouldn't sign up for honors. Okay, let's take a look at another example. Well, let me create one here real quick. Let's pick on a victim. Easy or hard one? Good, hard one. Let's take a look at a hard one. Let's go for this. Yes, okay. Yeah. Let's try this. Okay, example number 2. Let's go for this. Y is equal to, oh, what are we going to get from this puppy? Oh, we're scooted up so you can see. What are we going to get from that? X cubed. What are we going to have then? Minus x. What are we going to get? What are we going to get? Plus 16x minus 16. All right, let's look at this one. So we got x cubed. What are we going to have? Minus plus, so it's going to be plus 7x squared. What are we going to have then? Plus 8x minus 16. Now, you'll say to yourself real quick, first step, just like the last time, we look, because we're taking out our notes and we're going through those steps as we do each one of these. We look and see, is there anything we can take out of all these? You're right, in this one, no, there isn't. So this one, yeah, we just got to go through. So then we list our potential factors. The next thing we do, list our potential factors. So we take our constant, the factors of -16, to our plus or minus 16, plus or minus 4, plus or minus 2, plus or minus, oh, I forgot 8, and plus or minus 1. We divide those by the factors of our leading coefficient, which in this case is 1, which is nice because it's just plus or minus 1. So kind of odd. Again, we've just got a leading coefficient 1. Yeah, we'll do one that doesn't have a leading coefficient 1. That's then it gets a little nastier, but which one's going to work? I'm going to be honest with you. I don't have a clue. I'm just going to guess and check to see which one works. Volunteer, what number should we try first? Okay, let's try -1. All right, try -1. And I usually start from the small ones and work my way up to the big ones. Usually start with 1 and then work my way up, Okay, so let's go for our coefficients for synthetic division are 1, 7, 8, and -16. Carry it down. 6, -6 is 2. Does that work? No, sad panda. Okay, let's try another one. Let's try 1. Carry down a 1. 1 times 1 is 1. Add that together is 8. That gets me an 8. Uh-oh, feeling good or feeling bad? Should be feeling good, because that's going to be 16. Oops, that doesn't add to 16. Haha, 0. Okay. So let's go through that, and let's go for, so what do we got? We got y is equal to, 1 is 0, so that means x minus 1 is what we divided it by. Let me write that bigger. X minus 1, that's what's left over, x squared plus 8x plus 16. Now again, you're looking through, you're writing things down more than just what I write down. If I wanted to just write this down, I'd make a copy of it, but you're in honors. You got to start writing stuff down that the teacher helps you with that doesn't write down for you. Because I've got this down to a squared now. I can factor it. What is that factor to? Take a second to try it out. And that's x plus 4 times x plus 4. So in other words, that's a squared. So notice, what's the degree up here? There's a 1 right there, even though we're too lazy to write it. This one, because it only happens once, so that's called a single root. Only happens one time because this has a degree of 2, and that is a double root, because it happens twice. Now, a single root, what's it look like? A single root, there's going to be one at 1, because x minus 1 is a factor. Set it equal to 0 and solve. That means 1's going to be our root. That means it's going to go straight through. Now, is it going to go like this or like this? I don't know, but it's going to go straight through it. What's a double root look like? X plus 4 squared, set it equal to 0. That's going to give you x equals negative 4. So it's either going to look like this or like this. It's not going to go through it. It's just going to bounce off it. And I don't know which one it looks like. It looks like that or that. But it's going to look something. It's going to look more like a parabola in the local region of the graph. So in other words, notice it's to the first power. It looks really like a linear equation at degree 1 in there. A double root's going to look like a second degree equation. Stop and check out. Questions on that? All right, so since we got this, let's set it equal to 0 and solve. So x minus 1 is equal to 0. X plus 4 squared is equal to 0. Solve both of those out. X is equal to 1. X is equal to negative 4. Okay, so let's talk about the graph. So let's actually put this one together and put it in a graph. Okay, so we're going to have one at 1. We're going to have one at negative 4. Okay, so we know those 2 points for sure. We can find the y-intercept by plugging 0 into our original equation. In fact, we don't need to look at that right now. Okay, now what's it going to look like? Is it going to go like this or like this? Is it going to go like this or like this? Is it going to go like this or like this? Is it going to go like this or like this? Well, how do we determine that? For the graph, how do we determine something called end behavior? And what is end behavior? End behavior is what's happening as a graph goes to negative infinity and to positive infinity. In Algebra 2, we don't talk about something called limits, but you'll hear that word in pre-calc and in calc. The only two things that matter is what is your leading coefficient and what is your degree. If your leading coefficient, it's either going to be positive or negative. Your degree is either going to be odd or even. If your leading coefficient is positive and your degree is odd, it's going to start at negative infinity. It's going to end at positive infinity. So in other words, this is telling you where it starts on the left and where it goes to on the right. If your leading coefficient is positive again and it's even, it's going to look like a quadratic, which remember looks like that. So it's going to positive infinity on the left, positive infinity on the right. If it's negative, it's the opposite of if it's positive. If it's negative, a parabola that's negative would look like that. Negative infinity, negative infinity. So that's a really bad infinity there. And again, who's ever subbing for me today, if you need to pause it for a second, that's totally fine. That'll be able to get you some more details on what's happening. You may need to, of course, get the volume up. I'm talking a little bit late today because my voice isn't what it should be. But okay, so what do you got to do after that? Okay, so let's look at this one. Let's look at our original equation too. Look at our original equation. Original equation, what's the degree of this puppy? 3, is that even or odd? Odd. What's our leading coefficient? 1, is that positive or negative? That's positive. So we've got an odd degree, positive leading coefficient. Let's go through. So we start at negative infinity. So that's where this one starts over on the left. We got that from down here. So we're going to go from negative infinity up to here. Now, does it cross here or bounce? At -4, it was a double root, so it's just going to bounce. Going to go until it gets to 1. Now 1, does it cross or does it bounce? Just happened one time, so it's going to cross. And then where does it end up? Ends up at positive infinity and smiley face. There we go. Not a perfect graph, not a great graph. We will make it a little bit better graph, but for right now, that's what we got. Now, real quick, just a reminder, because I'm gone. You'll notice I'm emphasizing this a few times. If I'm gone, that's no excuse why I shouldn't learn. You should be paying attention the whole time. You should have that cell phone put away so it's not distracting you. There's plenty of time to talk on your cell phone, and now isn't one of them. Trust me, that boy or that girl texting you, they can't wait till after class. They aren't the right one for you. They'll find somebody else who will text them during class instead of getting their work done. So let's take a look at one more. Let's do the whole shooting match. I'll have you try it on your own, then we'll go through it together. Let's take a look at, easy or hard one. Oh, why not? Let's go for a hard one. Give me just a sec. In fact, take a 5-second break. I got to come up with a hard one here. Oh, yeah. This is a good one. This is a very good one. Good. Okay, here we go. Y is equal to, let's go for, let's go for 6x to the 4th minus 24. No. Don't want to yet it out. No, we'll trick you with this one. Minus 24x squared. What are we going to go for then? Minus 4x to the 3rd minus 16x. Let me make sure I got these all right. 2, yes. Multiply it all. Yes. Now, look at this one. Is it in standard form? No, it's not, so we should put that first. 6x to the 4th minus 4x cubed minus 24x squared minus 16x. What do we do first? We don't find the factors first. We take out what they have in common. What do all these have in common? Now, we got to take it out. So we got a 2x. So we take that out. Cell phone's away. I saw that even from Denver. I saw that phone coming out. Don't be that guy / girl. So take that out. 3x to the 3rd. What's that going to be? Minus 2x squared minus 12x. And then what do you have? Minus 8. Okay, now we look at the factors, but are we going to look at the factors of what's there or what's left over? We're just going to look at what's left over. So we're going to look at -8 over 3. Just a second, I got to give my arm a rest. So our potential factors of -8 are plus or minus 8, plus or minus 4, plus or minus 2, and plus or minus 1. On the bottom, plus or minus 3. Okay, let's take a look then. What are our potential factors though? So we're going and plus or minus 1, thank you. 1 is a factor, 3, 2. So we got to do a little matching up here. So we're going to have plus or minus 8 over 3 is 1, 4 over 3, 2 over 3, 1 over 3, and then all divided by 1 as well. So it is a matching game. You got to match each one of those up with each one of those. So plus or minus 8, plus or minus 4, plus or minus 2, and plus or minus 1. right, so which one do you want to try first? Always assume your teacher doesn't hate you first. So don't try these nasty fraction ones. I am letting you know one of these fraction ones is going to be needed. But I'm going to let you try one on your own. I would try these before I try these. So try some of these out first and then go from there. I am going to take a couple minute pause from the video just real quick to check it out. So who's ever subbing for me, go ahead and pause it right now because I'm going to drop. All right, so let's take a peek. Which one do you want to try first? All right, heard somebody say 2. Let's try 2. You want to try 2 or negative 2? Try positive 2. So let's go back up to our coefficients up here. They're going to be 3, negative 2, negative 12, negative 8. Let's try 2 in there first. So 3, negative 2, negative 12, negative 8. Carry that 3 down. 3 times that is 6, 4, 8. And you should be just as fast as I am at synthetic division by now. You're doing it, not used to it. To be honest with you, if you're not, that's probably a sign maybe you didn't do the homework. That's not a homework assignment that's going to be real quick. Don't do it. Let's take a look there. What do we got here? Negative 4 times that is negative 8. Hold on just a sec. I feel like I forgot something here. That's going to be a negative 8. Did I copy this right? I felt like that was supposed to work. 3, negative 2, negative 12, negative 8. 3, 4, negative 4. Yep, that didn't work out. That means bears. Give me just a sec. That should have worked out. What did I do wrong here? 3 gives me a 6. 4 gives me an 8. And negative 4. Oh, that should give me a negative 8. 16. Hold on just a second. I gotta figure out. I made a mistake here. Pause for a second. Ignore my errors. That is supposed to be a plus 8. That is supposed to be a plus 8. That is supposed to work out to 0. Oh, it's a plus. Darn glare. Crazy kids. Change that to a plus. That's why none of your factors are probably working out. Now, here's the question that's going to be, what if I used a different number first? That's totally fine. That's totally fine. That's totally fine. But when you get down to the final factors, they'll end up the same as everybody else's. So let's say you tried a negative 2 first, which I know works out too. Can you keep going with that? Absolutely. You should get the same factors. So let's write what we got out. So that worked, 0. So what do we got? A 2x times our factor that worked was 2. So it's x minus our factor. What's left over? Remainder, constant, x that. So 3x squared plus 4x minus 4. Now, you got a couple choices right now. You can factor this, If you'd rather, you can just keep using synthetic division. That will actually find all of your factors if they're rational. The only way you wouldn't is if there's none of those factors work. So that's your choice at this point. I'm going to factor because I know if it's going to factor, factoring will always work and I won't have to try more than once. So I go off to the side. What do? I factor negative 12. I factor 4. Okay, what two numbers multiply to negative 12 that add to positive 4? That's going to give me a negative 6, no, positive 6 and a negative 2. Now remember, because don't just put them into two terms. That doesn't work, people. You got to think. You got to move these into two terms. Why? Because the leading coefficient is not equal to 1. That's not how factoring works when leading coefficient is equal to 1. Minus 2. So then what do we got? 3x squared plus 6x minus 2x minus 4. And don't forget, then we factor by grouping. Factor those two. What do these two have in common? They have a 3x. What's left over when you take that out? X plus 2. What do these two have in common? A minus 2. What do we do? And that's left over, x plus 2. Right, so there's our factored form. How do we find our x-intercepts? We said one of those equal to 0. What do we do here? What do we do here? Ooh, this one's a little bit tougher. Plus 2, plus 2. And what do we do here? All right, so that's where it crosses our x-axis. Notice every one of them is just of degree 1. Is just of degree 1. So when we look at our graph, there's going to be a 0 at 0. There's going to be 1 at 2. There's going to be 1 at 2/3. There's going to be 1 at negative 2. Okay, how do we know where to start or where to finish? Well, we got to look. What was the degree of our original problem? What was the degree of our original problem? It was 4 with the leading coefficient of 6. Look at that little chart we just made. The degree is even because it's 4. Leading coefficient is positive, so we're going to start at positive infinity. We're going to end at positive infinity. Each one of these is single, so we just go through, go through, go through. And there we go. So at this point right now, that's what you got to be able to do. Give them one of those polynomials. You got to list the possible factors, take out what they have in common, get your factors out, draw your graph of that. And at this point, that's what you got to do. And that's what you got to do on homework today. And hopefully I will be back on Tuesday for you. I'd be pretty surprised if I wasn't, but you never know. I wasn't planning on being this gone anyway. So see you then.